Hello everybody. We're going to continue with our 9.5 notes today, and then there's probably going to be a few changes to the pacing and to the schedule that was originally on the assignment list. So please do stay tuned for details, and I will be posting documents to show you guys how I want you to upload your assignments and that sort of thing. But let's get started today with the lesson for 9.5. We're going to continue in the notes where we left off on Thursday, and each class left off at a different place. So you can fast forward the video to the example that where we left off for your class. But I believe that zero period still needs to have question B here on the graphing calculator. So we're going to go ahead and start there. So we're going to go ahead and plug in on your graphing calculator. If you don't have it, pause real quick and go grab your graphing calculator. We're going to type in our parametric mode that x is t cubed here. And we have that y is equal to t squared. And remember that we are plotting this on the interval here that's given as -3 to 3. So set your window to be -3 to 3, and we can use the table to find the exact coordinates and then watch how we graph. Remember, we have to put the orientation on the graph as well. So once you have this all plugged in, and feel free to pause the video at any time if you're not caught up yet and plugging into your calculator still. You don't have to graph that first point for -3 because that's way far off the graph. So we're going to graph our first point on here, which is -8, 4. And then I have -1, 1. I have 0, 0. I have 1, 1. And then I have +8, 4. And this one does continue to go off the graph, so I will put some arrows on it in the end, just because it does say to graph from -3 to 3 inclusive. If you want to plot additional points, you can change your step in your table, the delta, which is the triangle, the delta table in your table settings to maybe 0.5, and then you could graph points in between if you're not quite sure about the shape of the graph. And that's using our calculators for parametric equations. So now we're going to look at eliminating the parameter. But the first thing we're going to do is we're going to make a graph. So you can use your calculator to go ahead and make that graph. If you want to pause the video, go ahead and pause the video here to be able to type it into your calculator and make your graph. So your graph should look something like this. And when you're making your graphs for these, they can just be sketches. You don't need to graph them on graph paper. They can just be a sketch. And then we're going to eliminate the parameter. So to eliminate the parameter, that just means to eliminate the variable t from each of these equations. So I can solve for t in one equation. If I take my, okay, we're back. If I take the first equation here, x is equal to the square root of t, and I solve that for t, I'm going to get x squared is equal to t. And now I'm going to take that and plug it into my second equation. So y then is equal to x squared plus 2. Now, we've eliminated our parameter and gotten rid of the t, so it's now just in terms of x and y. However, if we look at our graph, that's not exactly what's represented in our graph. And it says here to adjust the domain and the range of the resulting rectangular equation if necessary. So we know that this equation here gives us an entire parabola. We only want half of it, however, so let's restrict it. We know our x is greater than or equal to 0, and our y is going to be greater than or equal to 2. Now, before we actually even would look at the graph, we could find that restriction just based on the x right here. It's the square root of t. So can we take the square root of anything that's less than 0? Nope. So we know that t has to be greater than or equal to, the x has to be greater than or equal to 0. And we look at our y equation here. If our t value is greater than or equal to 0, because it's inside the square root on the x, then that means that our y value is going to have to be greater than or equal to 2. And there we have our final answer with our two restrictions. Example number 4, now we're introducing a little bit of trig. So again, take a moment, pause the video, and make the graph on your graphing calculator. And actually, even before you actually make your graph, think about what the restrictions of a domain would be and what the restrictions of the range or the y-coordinate once we eliminate the parameter would be. Hypothesize what you think they might be, write them down right now before you graph it, and then go ahead and make the graph. Pause the video so that you can write that down before you see my graph. Alright, so you should see the graph of an ellipse, and we have an ellipse that has a maximum y-coordinate of 4 and minimum y-coordinate of 4. If we look at our y value right here, y is equal to 4 times the sine of theta. So that being said, we know that the sine of theta goes between -1 and 1. So if we multiply that by 4, then that means the y is going to have to go between -4 and 4. So our restriction on y, I'm just going to write it down here at the bottom, our y is going to be greater than or equal to -4, less than or equal to 4. Similarly, if we look at the x is equal to cosine of theta. That goes between -1 and 1. That makes sense because the cosine of theta is restricted to -1 to 1 from our unit circle. So now we're simply going to eliminate the parameter. To eliminate the parameter here, we're going to use a trig identity. Oh yes, they come back to you. So I'm going to square each of my equations. So the first one, I'm just going to square the x equation. So it's x squared equals cosine squared of x. Sorry, cosine squared of theta. Before I square the y equation, however, I'm going to divide by the 4, and then I'm going to square it. And I have y squared over, or y over 4 quantity squared equals sine squared of theta. Now, if I take these two equations and I'm going to add them together, on the left side, I have x squared plus, now I have y squared over 16 is equal to cosine squared of theta plus sine squared of theta. Aha! And there we have it, our identity. What does cosine squared plus sine squared equal? Hopefully you said 1. X squared plus y squared over 16 is equal to 1. And we have an equation. We look at that. We know that that's the equation for an ellipse. And there we have our restriction. Perfect. Moving on to number 5. So now we're going to look at natural logs and exponentials. So these are all functions that we've worked with throughout the year. They're all coming back. Don't forget all of the rules and properties for each of the types of functions that we are working with. So before we actually make our graph on our graphing calculator, let's think about what the restrictions would be on the x and on the y values for this parametric equation. So if we're looking at the x's here, we have x is equal to natural log of 2t. So when we take the natural log of a number, let's think. The natural log of a number is going to have x values that are always positive. If you think about your natural log graph, you have an asymptote at x equals 0, and your graph is only on the right-hand side of that. So we know that our x restriction is going to be x has to be, I'll write it over here, x is going to be greater than or equal to, not equal to, because there's an asymptote there, greater than 0. And then our y is equal to 2t squared. Well, we know from the first equation here that we would not be allowed to plug in anything that's going to make that be 0 or negative. So we know that our t value has to be a positive number. Therefore, if t is a positive number, plugging it into here, positive number times 2 is going to give you, again, a positive number. So our y is going to be also greater than 0. Okay, now you go ahead and pause the video and make the graph. What you see should look like an exponential graph. And now moving on to eliminating our parameter. So to eliminate the parameter, again, we're going to take one of our equations. We're going to take that one equation and we're going to solve it for t. So let's say I'm going to take my x equation. So if I have x is equal to the natural log of the quantity 2t, and I want to get rid of the natural log, so I'm going to exponentiate both sides, and therefore that's going to cancel. And so now I have 2t is equal to e to the x. Last, just divide by 2. So t is equal to 1/2 e to the x. Now with that, I can plug it into my y equation. So y is equal to 2 times 1/2 e to the x quantity squared. So simplifying this then, I will have y is equal to 2 times 1/4, and then I multiply those exponents, so it's e to the 2x. And last, my fraction, y is equal to 1/2 e to the 2x. So I have y equals 1/2 e to the 2x. I have my restrictions here. x is greater than 0, and y is greater than 0. Wonderful. We will end this video here, and please see part 2 for the last 3 examples.